thank you for coming to the last session of Kotlin Conference 2018 before the closing panel. I'm Eric. I am an Android developer at Pinterest, and I work on a performance team at Pinterest, pretty much across the Android stack and everything that touches the Android app in that way. And I originally actually joined the Pinterest team, joined the performance team at Pinterest to work on serialization formats and to explore what we can do with serialization. And one of the things that's really captured my interest over the last year has been the Kotlin X experimental serialization library. And a lot of the concepts that it pushes, especially towards multi-platform and where that's going to push the Pinterest app and the industry as a whole towards multi-platform within the next few years. And as just so you know my biases, I work on a JSON serialization library called Moshi, and a lot of the things that I compare and contrast are in the API side of things are against Moshi, and where I see improvements and where I see things that are still lacking in the experimental API of the Kotlin Serialization library. So I have biases, and that's the full disclaimer. Also, another disclaimer is that I've talked about this library before, and in that time, in fact, in like the last 2 weeks, 0.8 came out, and a lot of the APIs changed. The really nice part, of course, about Kotlin is the deprecated API makes things super easy to convert, although a lot of the reading and writing, if you get into a lot of custom serializers, a lot of those APIs have changed. And so especially for those watching on the video, a lot of this could change. A lot of the actual APIs and implementations could change. And hopefully a lot of the abstract ideas still apply, especially towards multi-platform and a lot of the basic concepts going forward. So first of all, why? And the first thing you say is, well, Kotlin. That's it's just Kotlin code, and that's great. But then why? How many people use JSON as a primary serialization format? That's a lot of people. How many protobufs? Yeah. How many people like message pack? Yeah, we got some people with message pack. The cool thing about the Kotlin serialization library is that it's unopinionated about a lot of these things. In fact, you could sit a lot of serialization libraries behind the Kotlin serialization library and just use their implementations. Again, assuming that they support multi-platform. And so the first thing you say is why, and you say Kotlin. But Wire, the Square's library for protobufs, it's working towards generating Kotlin. And Moshi also generates Kotlin adapters. So a lot of existing libraries actually support Kotlin already. So the second reason is it doesn't use reflection. In fact, a lot of serialization libraries in the past, for very good reason, have relied on reflection APIs to make things really simple. And the Kotlin serialization library actually uses a compiler plugin to generate, on the JVM side of things, bytecode for you. And so this is a really new concept, and it's extremely performant that way. And also, Kevin Most yesterday gave a talk about Kotlin compiler plugins. You can go back and watch that. I certainly want to implement something in the future for existing libraries. So it's extremely performant. Doesn't rely on reflection. Also, it doesn't rely on reflection APIs that would be tied to the JVM. So a lot of existing libraries you might use in the JVM or Android rely on types to understand how to serialize types, whereas the compiler plugin all does this statically at compile time, so it doesn't need to know anything about reflection APIs, which is something really hard to compete with, and really no library that I know of for any serialization format right now on the JVM competes with it in this way. And then the third reason is that it's multi-platform. And then this is really the huge thing that I think is going to drive all the other libraries to compete, especially once the serialization library gets to 1.0, gets to a stable release, is there's nothing right now that'll compete multi-platform. Native is not implemented yet, but I mean, we're confident that it will be at some point, and so this is the only existing solution you have for your multi-platform projects that need to support JavaScript and bytecode. To get started, like I said, this uses a compiler plugin. So we need to, assuming you're using Gradle, pretty easy to apply these, to apply this to your build script, and make sure you actually have that in. Otherwise, none of your actual bytecode will get generated, and you'll run into compiler errors. Also, a huge thing that when I first got started, I missed, and it's super easy to miss, and compiler plugins need IntelliJ plugins to go with them. This isn't, because it's not a stable release yet, isn't published under the IntelliJ. Just go into your IDE and search plugins. It's not going to be there, so you need to go to the GitHub repository and download your IntelliJ plugin and keep it up to date manually. But if you don't do this, you're going to get everything to compile fine, but you're going to see plenty of errors in your IDE in IntelliJ that are going to look really weird, and you're not going to be able to make sense of them without this. Also, Alec and Igor gave a talk just like 30 minutes ago on implementing IntelliJ plugins, so that goes hand in hand with compiler plugins. If you're going to implement a compiler plugin, you'll probably want to implement an IntelliJ plugin to go with it to make things make sense in the IDE when you're generating bytecode. So to run it, very simple for the simple case. Classes that you want to have serializable have to be marked explicitly as serializable. This is really great so you don't accidentally end up serializing platform types, and I'll get to that in a minute. Types that, so it kind of that's a kind of a side effect, is that you have to be explicit about types that are serializable. And then the serializable annotation is actually the primary purpose is to serve as a hint to the compiler plugin that the actual adapter code, the actual K-serializer code, has to be implemented here. So when you mark a class as @serializable, a K-serializer, and we'll get to that in a minute, instance will be implemented. And also, you'll notice here this serializer extension function will be implemented on the K-class instance for that type that you've marked. So the just like hello world example is super simple here. We can get our JSON instance or a protobuf instance, and we can start serializing this class right away. And if we actually need the K-serializer, we can get that with the extension function that's generated. So by default, those first two things you'll see there where we're like just JSON, stringify this thing, serialize it. You'll notice we're not passing in any serializer, but there's an overload to pass in the serializer. You probably want to use this when you can. By default, if you don't pass in a serializer, it will grab the default serializer from a global map, so you have a lot of static state. And this is kind of the first awkward point of the API, is there's no factory API. So if you're not into keeping the global state, and if you need to actually inject these things, inject these K-serializer instances, there's not a general client way of doing this. So you need to pass these things around. You need to pass these case serializers around and actually pass them in when you need to. And there's no factory API, so there's no delegation like we see in things like JSON or Moshi. And this, when we get to it, we're going to be implementing a case serializer in a couple minutes. And you'll notice there's no actual like delegation, so it makes things a little bit more complicated. But you do want to pass around these serializers so that if you ever need to change the implementation, especially like in debug modes, make like a more strict serializer, you'll need to pass these things and inject them manually. And also, one of the actual nice parts about this API is their extension functions for getting a list and for getting sets and for getting map serializers right off your general serializer. So you don't actually end up having to implement an array serializer yourself or a map serializer. They're just extension functions right off that. And for map, it's an extension function off of a pair. So in that case, it's a map of a user to user. But in general, like you could have a int serializer or any other serializer you want to pass in there. You just need a pair, and that way you don't have to implement your own map logic for your own serializer. Because as you'll see in a few slides, implementing your own serializer isn't extremely user-friendly yet. So here's where we start running into like more complicated cases, because as users of serialization libraries, we know like our data is never as simple as the hello world example. So you'll notice there's a lot of cases where we have like qualified types that we want to serialize differently. This is typically where a very typical example is where we have like on Android, we represent colors as integers, and sometimes our server says, I represent them as a hex string, and you want to say, okay, this integer needs to be deserialized from a string instead. And the very simple way to do it is we can do an @serializer, and we can specify the k-serializer instance that we want to use here. This is very reminiscent of JSON's @JSON adapter annotation, where you can specify a custom type adapter or type adapter factory on a field in a class. This is pretty much exactly that. There's also another way of doing this, and this is more reminiscent of standard type qualifier APIs that you'll see in things like Moshi. And this type qualifier is a little bit different and actually is more of a metadata type qualifier. It's called serial info, and so you specify your own custom annotation as a serial info, and then you can annotate your properties with this. And we'll see in a minute how we actually get these things out. And this is a more advanced usage because this is something we'll have to implement our own k-serializer for to be able to pull off data from this. But we can also specify more complicated things like custom properties within the annotation that we can pull out, as we'll see in a minute. And another common example is custom names. So sometimes our encoding names, our encoded names, are different from what we want in our source code at like the Kotlin level. I'd say, as an opinionated person, I generally don't advise doing this because it's much easier to have your names in your source code to match up to what they are in encoding. But sometimes this isn't possible, like in this case where we have a space. There's no way to represent this in Kotlin. It would be an illegal character. So serial name is the way to do this. This is similar to standard serialization libraries typically give you a way to do this. And then another thing is lots of So optional is a big thing in data classes, especially. Data, we can have default values. A kind of weird thing here is this won't compile correctly because we haven't, if it's optional, it's, we haven't given it any optional value. So if this isn't in, when we're like decoding, and if this value, this number just isn't present, like there's nothing to do with it, it's not really optional because we haven't given an optional value. So the correct way is, of course, to give it the optional value, what it is when it's not present. It's a little bit awkward because you still have to specify it at optional instead of optional just being inferred when you have a default value. So you just remember to be explicit with the add optional annotation here on your property. And then nullability, as you expect, just works. This will now take nulls, and if it's not specified as nullable, then you'll get a runtime exception when you're decoding something, and that property is null or absent. And here we get into custom serialization. This is actually an API that's changed in the last 2 weeks, so this is one of those things that very much could change in the future, so just like take note of that. And so like I said in our Hello World example, it's super easy. We can just @serializable, and then this K-serializer is just implemented for us. And sometimes we want custom logic here. And so we can implement K-serializer ourselves. And we do that on any object. It's common practice to do it like on a companion object if it's a type that you own. And you just need to specify for which class this is. And you'll notice here I have these override keywords on the serialize and deserialize methods. But this companion object isn't implementing any interface or anything. So what is it overriding? And my IDE is going to complain. It's not going to complain if you install the IntelliJ plugin. Again, this is why the IntelliJ plugin is basically required. It'll compile fine, but you're going to get warnings, you're going to get errors in your IDE about the override there. The other thing you could do is tell it to implement K-serializer. You could do this explicitly, but then you're going to, and we'll get to it in a minute, there's also another property that the K-serializer interface requires, which is a descriptor, which it contains a lot of metadata. And if you don't want to, and you probably don't want to implement all the metadata yourself, you should just let the compiler plugin do it for you. So I'd recommend just not implementing the K-serializer directly. Just leave that off, and then leave the override for serialize and deserialize as you want, and let the and then the compiler plugin actually looks at the serializer annotation and makes the companion object, in this case, implement K-serializer for you in the actual bytecode. And this is where I said having the explicit serializable annotation is so important, because now platform types, you can't get away with accidentally trying to serialize these. In things like JSON, JSON will just try to give you, in JSON they're called type adapters, but like a K-serializer in this case, it would just give you a type adapter for platform types, which is really dangerous because platform types can change. Any type that you don't own can change, and then you've encoded data a certain way, but then if you're not using the public API for that, you've encoded private implementation details of that API. And when that platform type changes, which it will, the implementation details of it will change. Then if you're not using the public API, you'll try to deserialize it incorrectly in a later version of that and run into all sorts of errors. So you need to explicitly implement custom K-serializers for your platform types. And in Moshi, it does the best it can. It'll throw a runtime error when it recognizes common platform types. But in the Kotlin Serialization library, you'll get a compiler error if you haven't explicitly explicitly defined your custom serializer for these platform types. So a common case here is like java.util.date, and you actually need to implement this yourself. It's of course worth noting that common types like string, core types, primitive types like string, int, long, short, etc., are and arrays and maps and lists are implemented already case serializers in the standard library, because those are interfaces, not and they're interfaces and primitives, not implementation platform types. So here we're going to get again an error. We're going to get an error if we haven't installed the IntelliJ plugin, because we haven't implemented our custom descriptor, even though we have the case serializer there. But if we install it, if we install the IntelliJ plugin, that warning will go away, and this compile is fine anyway, because the compiler plugin actually implements all the metadata for us. So the case serializer is made up of two types: a serialization strategy, which is the actual like encode or the encoding part where you serialize, and this you implement with an encoder. So like in Wire, this is called like a proto reader, or in JSON libraries, typically called like a JSON or a JSON writer. In Wire, it's called a proto reader, and then our object that we actually need to encode, and then a deserialization strategy, which is the opposite, a decoder or a reader. And then we have what I keep talking about our metadata, our descriptor. And for the most part, we don't really need to worry about this, but we will come back to it when we need to think about our serial info annotations and for more custom use cases. But generally, like, this contains the metadata about our name and helps us out with error messages a lot. But we don't need to worry about this because it's in general, because it's implemented by the compiler plugin. And so, like I said, this is where we can get our serial info annotation. So we can get our get annotation for class. We can pull this out from the descriptor when we're implementing a custom serializer. The other great use case for serial info is if you have a custom serialization format. This is a great way of just like putting extra data into our case serializer that can't really fit anywhere else. We can just slap it into an annotation and pull it out in our case serializer. This is the way that we can get a serial tags for protobufs. And so it's got a lot of like wide use cases. And so let's say we have this generic type, and we want to implement our K serializer for it. So we have our custom serializer, and we say like it's going to be for this pair type, and we're going to need to pass in the things we'll need to delegate. And this is where I say there's not really a like general client instance where we can pull these things off and delegate. So this is this is a place where we're going to have to pass in all of our dependencies very manually and get the case serializer for these generic types that we'll need, and then actually use them in our implementation, rather than having like a client instance where we could pull them off and delegate. So in this case, we can see where we can pull off the metadata if we wanted to from our descriptor, and this is basically how we delegate. And as you can see, like, implementing this stuff is and again, like, these APIs have changed in this is updated for 0.8, but like these APIs are pretty volatile right now. And this stuff is, if you've ever implemented like custom adapters for JSON formats or protobuf formats, like this is pretty complicated. And again, that reason is because the Kotlin Serialization library has to have these abstractions, because you could sit any serialization format behind it, and it has to know. So you have to very methodically like tell it what you're trying to do with the data, and then have your serialization format understand that and implement these methods here, or these functions properly. So a lot of this complexity comes from that abstraction, the need for that abstraction. So in this case, we're trying to load up just a map type, basically. And then here's more of an example of where we're encoding an array type, so like a collection type. And just to like show off more of a broader spectrum of the API, and again, like we have to like pass in the indices, because your serialization format could care about a lot of those things, and need to tag things differently in the implementation of your serialization format. The nice part is that generics can be simple. Again, if you don't need to implement a lot of custom logic, generics can be pretty simple. In fact, if you just mark your class as at serializable, before I talked about how the serializer function, extension function, gets generated automatically on your K-class instance. And if you have a generic class, the serializer function, extension function that's generated on the K-class will actually take in the K serializers for the types that are generic in there. So again, you still need to wire all these things up yourself. You still need to pass in your own K serializers, but it is nice that you're not writing a lot of extra type information into your code. You can just use the extension function that's generated for you. And a lot of us, though, are still, so if you're not using multiplatform, a good way to adapt from Java types, there's this thing in the standard library, in the serialization standard library. There's this function that will just get us K serializers directly from your java.lang.reflect.type types. So this is a really good way if you're still migrating like an existing library that understands Java types into K serializers. It's also a good way of sitting existing JVM libraries behind the Kotlin serialization interface. Out of the box, we have 3 formats given to us, and the really important part is that we can implement our own and actually just use the K serializers ourselves, as long as we implement all of those very abstract functions ourselves. And the JSON's a string format. The other 2 here are byte formats. So it kind of leaves us, as you'll notice, like these functions aren't named similarly. They both have, or all of these have functions for encoding and decoding, but their function signatures are really different. And unfortunately, this is still kind of a quirk in the library, where this makes abstraction really difficult, especially if you're building libraries on top of the Kotlin serialization library. And this, how many people use Retrofit? Okay, a lot of people use Retrofit. So Jake has a converter factory for, Jake Wharton has a converter factory for the Kotlin serialization library. The thing is, it still has a lot of like kind of an overly complicated, it's still a very easy API, but an overly complicated API because of the lack of the abstraction. So you can follow this issue, and then hopefully in the future we can have a more unified API for our different serialization formats so that they all conform to a standard type. Right now, and you kind of see this as a theme where we're still in the mode of a lot of libraries now that use the Kotlin Serialization library have to implement something similar to this. So we all end up with custom loaders and savers that that understand strings or bytes differently, so that we end up implementing our own abstractions on top of the JSON or protobuf or CBOR and or any other encoding formats that you might have. So hopefully something like this just gets propagated up into the Kotlin Serialization library, so that every single library that's built on that uses the Kotlin Serialization library doesn't have to define its own types or type aliases for this. And so like I said, JSON string-based. So just using the converter factory, it already provides this API where we can say, hey, I have like JSON or whatever my string-based encoding format is, and then we have a byte-based API, and you could also use the byte-based API, of course, with JSON, and it's just a little bit more obtuse because of the lack of the abstraction. And then we still need to like pass in our method references for encoding and decoding. And again, all of this can be lifted out of the API if we ever get an API that standardizes like the functions that if JSON and protobuf implementations implemented a common interface for encoding and decoding. And so one of the big things here is that the Kotlin Serialization library has a lot of this abstraction for good reason, because it needs to understand all of your serialization formats. And this the unfortunate part is that as soon as we get into complicated cases where we have to implement our custom serializers, we have to understand a lot of the low-level pieces in the API. So that's one of the costs of having a library that understands lots and lots of encoding formats. The other thing is, as you notice here, there's no streaming API. So we actually end up we'll have to buffer our entire byte array or our string here in the case of JSON to be able to pass it into our interfaces. So there's no streaming API. That said, it's extremely fast, and especially when you already have things in memory, there's no reflection, and it's not even relying on any reflection APIs to get the references to your K-serializers. And that comes at the cost of understanding where your K-serializers are more on the global static map if you're not passing them around manually. So there's still room for a factory API, but it's something that that we'll have to like implement ourselves to be able to pass around our K-serializer instances much better. The other thing that the Kotlin Serialization library, as I mentioned, does kind of nicely is that the K-serializer is broken up into both a deserialization strategy and a serialization strategy. This can make things really nice if you're going between API boundaries and you want some code only to be able to serialize formats or only to be able to deserialize formats, or if you just want to implement one of those things. I see a lot of custom serialized adapters in say Mashi where we only care about decoding things. And so we have to implement a lot of boilerplate to throw like unsupported operation exceptions when somebody tries to encode things, or because like we just don't care about the case, or it would be illegal to, it would be an illegal state to, or even like the logic might just be too complicated. So it's nice that these things, that it's kind of broken up into that. And again, it makes libraries like the Retrofit converter factory very nice, because we can just pass in, it just understands Serializer, or it just understands serialization strategies and deserialization strategies. Those names changed in 0.8, so those are the new names. As part, instead of the overall Serializer that makes up both of those. And yeah, so try it out. Like I said, there's still things to improve on, and there's still a lot of things that are going to be built on this. I think it's really a drive forward towards multi-platform, especially when it gets native, when native is implemented for it. And I think it'll inspire a lot of libraries in the future. It's kind of inspired a race to get to multi-platform across serialization libraries in the next coming years. And attend the panel afterwards. Thank you. Right, so that's where, actually, yes, so what happens when I have different like API endpoints that understand dates differently? And this is where we can use things like, so what happens like when I want to deserialize a date as differently than deserializing a date in a different place. So this is where we can use the @serializable annotation and then give it a different serializer for your different types. So like in this data, we might want to, this could be like a date instead of a long here, and we could say, hey, I want to use this Serializer for this, but then we could have another property here that then has another @serializable, and then do with like a different RFC type Serializer for a different date type. The other way, like I said, would be to, if you want to go the long route of implementing another serial info and then grabbing it out of a different serializer. But the really easy way would just to be to use this API. Yeah, so the question is about what I typically call polymorphic deserialization, where we have the classic example of like an animal, and then we have like maybe a field that says the type is a dog, and then I want you to deserialize it a different way, and then another type might be a cat, and we need to deserialize it a different way. So we don't know statically, when we're building the app, like what type it might be, and we need to understand this dynamically when we're deserializing. No, there's really no good API for it currently in the serialization library. Yeah, it's one of the limitations right now. Yeah, so the question is, when will the work be started on Mashi for multi-platform? Well, OKIO2 is the first step in getting to multi-platform for OKIO. And yeah, I think there's still a lot of work to be done in OKIO to get to multi-platform. I think that's the first step. Mashi, I think it's really close to being at the point where it can be moved to Kotlin, and I mean it generates Kotlin adapters for us. The tricky part, like I've said, in libraries like Mashi, is that it understands types, so it's very tied to the JVM, because of the factory API. And the factory API is super handy because then we can have a lot of delegation and pull things off of the Mashi client instance. But the unfortunate part about that being all at runtime is that it understands Java types. And or alternatively, if it were just straight migrated to Kotlin, it might understand K classes, but the reflection APIs aren't in Kotlin Multiplatform, and also the reflection to get the reflection APIs that Moshi would currently need to understand everything, it would have to bring in the full reflection library, which would be huge and very slow. So there's some obstacles still. But yeah, there's OKIO is the first step, and then yeah, and then there are a few interesting alternatives to the existing API in Moshi that could be done in the coming future. Adding support for metadata in the serialization. So in the, I think if you implemented your own K serializer, you could add a lot of that metadata. I think right now it's still like a very manual process, as far as I know. Yeah, having two stages in the K serializer. There's no like built-in API, so you'd have to implement a custom K serializer for it. Cool. Yeah. Thank you.